33 kilometers. That's all it takes to move a fifth of the world's energy. Now imagine it stops. Not reduced, not delayed. Stopped.
The Strait of Hormuz remains one of the world's most critical maritime choke points, with unprecedented congestion blocking the flow of global energy.
20 million barrels, with nowhere to go. Oil, gas, chemicals, food systems, all waiting behind a single line on the map. Prices react first, then supply chains, and then something more dangerous happens. The system starts to slow down in ways it was never designed to handle. Because this isn't just a disruption, it's a bottleneck with no replacement at this scale. Everything you just saw, all of it traces back to one place.
The Strait of Hormuz is the world's most critical maritime choke point. The ripple effects of congestion here are global and immediate.
The Strait of Hormuz. A narrow passage, just 33 kilometers wide at its tightest point. But every day, nearly 20 million barrels of oil move through it, close to a fifth of the world's energy supply. Now here's the part most people miss. This isn't just one route among many, it's the route.
You see, infrastructure isn't just the final structure.
Watch that dozer.
It begins long before, right here, carving the very path for everything else to follow.
Every barrel from Saudi Arabia, the UAE, Iraq, Kuwait has to pass through this single gap to reach the open ocean. There is no alternate highway running parallel, no second channel waiting as backup, just one corridor. And that creates a strange kind of imbalance, because on the surface, the global economy looks massive, distributed, complex, but underneath, it's tightly concentrated, compressed into a few critical points where everything has to pass through.
The world doesn't run on open networks, but on a handful of overloaded nodes. Look at how all routes visibly compress.
This is what engineers call a bottleneck. And in this case, it's not just a technical constraint. It's a systemic one, a single location that carries the weight of an entire global network, which means the real risk isn't how much oil the world produces. It's how much of it depends on one place to keep moving. And when everything depends on one place, that place becomes the most dangerous point in the entire system. You might expect a system this important to have a backup, a second route, a parallel network, something ready to take over if this one fails.
Redundancy is key, but the real question is, can these paths truly replace the main route?
It doesn't. There are pipelines that try to bypass the strait, but they only move a fraction of the flow, not enough to replace it. Not even close. There are strategic reserves, millions of barrels stored underground, but those reserves don't fix the problem. They just delay it. They buy time, days, maybe weeks, not a solution. Because what's missing isn't oil, it's movement. The entire system depends on continuous flow, tankers loading, ships moving, refineries receiving.
This system is alive, a continuous artery of global commerce. Everything depends on this uninterrupted flow.
Break that flow, and everything downstream starts to stall. Now here's the critical part. There is no system in place that can replace this volume at the same scale. No alternate route that can absorb 20 million barrels a day, which means the global energy network is not built with redundancy. It's built for efficiency. Every route optimized, every process streamlined.
The system runs smoothly, but only because every lane is filled to capacity. There is no redundancy.
No excess capacity. No spare system waiting in the background. And that's where the risk comes from. Because efficiency makes everything faster, but it also makes everything fragile. When one part fails, there's nowhere for the pressure to go. No second path, no release valve, Just a system that was never designed to take a hit like this. If the world can't go through the strait, then the only option left is simple. You go around it, not with ships, not with rerouting, but by building an entirely new path, a second exit, a new connection between the Persian Gulf and open ocean that never touches Hormuz.
This is where the work begins. Bypassing the choke point is not a finished solution. It's a reality just taking form.
Shorter than the Panama Canal. But this isn't jungle. This is hard. Fractured limestone. Steep. Unstable. And in some places, hollow.
Every meter is accounted for. Control and understanding start at this granular level.
Solid rock, dozens of kilometers across, rising hundreds of meters above sea level. No roads, no infrastructure, no existing route, just terrain that was never meant to be crossed by anything, let alone supertankers. The shortest possible route is around 30 kilometers, which means every meter you cut has to be measured, mapped, controlled. Because one wrong blast doesn't just slow the project, it can collapse the entire section. So the idea is simple. Cut through the mountain. Create a new waterway, but in reality, this isn't just building a canal, it's rewriting geography. Because when the system gives you no alternative, you don't find another path, you create one. But now the story changes. Because this is no longer just an engineering challenge, it's a money question, a power question. A project like this doesn't cost $200 billion because it's big. It costs $200 billion because it changes who controls the flow. And that makes it something very different. Not just a canal, a new global artery. So who pays for that? Not one country alone, not easily. Because the moment you finance the route, you also claim influence over it. That means the Gulf states could fund it. They depend on this exit more than anyone. But if they pay, they also have to share control of the new path. An international coalition could step in. That sounds logical. Until you remember what this really is. Not just infrastructure, leverage. A private consortium could try it too. Energy firms, shipping giants, sovereign funds. But private money never builds at this scale for charity. It builds for access, for tolls, for decades of revenue tied to one of the most strategic flows on Earth. And here's the deeper truth. A canal like this doesn't need to be finished to start changing the world. The moment the project is announced, markets react. Risk drops, insurance reprices, capital moves. The route begins to matter before the first ship ever enters it. That's how powerful infrastructure can be. It reshapes behavior before it reshapes geography. So the real question is not just, can it be built? The real question is, who wants control badly enough to pay the entry price? Because at this scale, the concrete is only the visible part. Underneath it is something bigger. Influence, access, power over movement itself. And once a project reaches that level, it stops being a construction story. It becomes a geopolitical one. Before the first section is cut, before the first blast is placed, before the canal even begins, something else has to be built first. Everything around it, because a project like this does not begin with excavation. It begins with access. There are no highways here, no rail lines, no power grid waiting in the mountains. So the first construction is not the canal, it's the road to the canal, kilometer by kilometer. Crews carve access routes into rock just to move equipment into position. Temporary jetties rise on the coast. Heavy machines come ashore one by one. Now the site can breathe. But it still cannot work, because 10,000 workers cannot survive in bare mountains without water, and there is no fresh water source nearby. So before the excavation starts, a desalination plant has to be built, Pipes first, pumps first, storage tanks first. Only then can the workforce stay. Then comes power. A canal on this scale doesn't run on diesel trucks alone. It needs a permanent electrical backbone, drills, crushers, lighting, pumps, control systems. All of it needs energy long before ships ever arrive. So the power station comes before the waterway. This is the hidden phase of mega construction. The part no one sees, the part that decides whether the visible part can even happen. Worker camps rise in the desert, medical stations, fuel depots, repair yards, supply storage. A whole industrial city appears just to support the future canal. And that is the real lesson here. The biggest projects on Earth are never built from the center outward. They are built from the invisible outward, roads before rock, power before excavation, water before labor. Only when the support system is alive can the main structure begin. This is no longer just a canal route on a map. It is now a functioning construction machine. And with the roads open, the water flowing, and the grid online, the mountain can finally be challenged. Now the real work begins. The mountain has been surveyed, the roads are in, the crews are in position, and the first charge is placed. This is where the bypass stops being an idea on paper and starts becoming physical. Blast by blast, cut by cut. The first explosions are small, test blasts, measured blasts. Engineers watch how the rock breaks, how the slopes react, how the dust moves. Then the pattern is adjusted, and the real excavation begins. This is not one explosion. It is thousands. A rolling sequence across 32 kilometers of mountain, every section drilled, loaded, timed, then fired in controlled waves. In seconds, tens of thousands of tons of rock are broken loose. Then the machines move in. Excavators at the base, dump trucks climbing out, load after load, hour after hour. The mountain leaving on wheels, day shift, night shift, then day again. This never really stops. And where the open cut cannot go deeper, the tunnel machines take over. A tunnel boring machine drives into the hardest section of the range, cutting through the part the surface crews cannot safely remove. Now, two methods work at once: blasting above, boring below. One tears the mountain open, the other eats through its heart, and the numbers become hard to comprehend. 400 million cubic meters of rock, not dug, removed, broken, lifted, hauled, and taken away until a barrier that stood for millions of years is turned into a route for ships. This is not canal construction in the usual sense. This is terrain demolition, a controlled dismantling of geography itself. Every meter gained is permanent. Every blast changes the map. By the midpoint, entire sections of canyon already stand where peaks used to be. Wall faces rise straight up. Machines at the bottom look like toys. The scale blows minds. And when the final major cuts connect surface to tunnel, tunnel to open air, the impossible becomes visible. Not a plan, not a rendering, a path carved through solid mountain. This is no longer the dream of a bypass. This is the moment the mountain starts to lose choice. A second path, a second outlet, a second way for energy to keep moving. When the first one came under pressure, that changes everything. Not just for tankers, for governments, for markets, for anyone trying to predict risk. Because infrastructure does more than carry cargo, it redistributes leverage. The moment a second route exists, the old bottleneck loses part of its power. Countries that once depended on a single exit gain room to negotiate. Buyers gain flexibility. Insurers gain confidence. Traders stop pricing every Gulf crisis like the whole system is about to seize. That is the hidden force of projects like this. They don't just move oil from one sea to another. They reshape behavior. They change who can pressure whom, who can wait, who has options, and who suddenly doesn't. A canal like this would not just have made shipping more secure, it would have made the world less fragile. Fewer price spikes, less panic, less concentrated risk, and that means fewer regional crises turning into global ones. This is why strategic infrastructure matters so much. It does not just support history, it changes it. A single new route can alter trade flows, energy politics, military calculations, and the balance of power across an entire region. So, if this canal had existed 20 years ago, the map would look the same, but the system running through it would not, because once you change the path, you change the pressure, and once you change the pressure, you change the world that forms around it. This was never just a canal story. Not really. It was never only about concrete, or blasting, or ships, or even oil. Those are the visible parts. The deeper story is about flow. Who controls it? Who protects it? Who depends on it? And what happens when that flow is squeezed through one narrow point? Because that is how the modern world actually works. Not as one giant system spread evenly across the planet, but as a network of pressure points, a few narrow passages, a few critical routes, a few places where the movement of energy, goods, and money becomes concentrated. Control those points, and you shape outcomes far beyond them. That is the real power of a choke point. Not what it produces, what it controls, and that is why this matters so much. A canal like this would not just move tankers. It would change leverage. It would reduce pressure in one place and create new influence in another. It would alter decisions made in boardrooms, ports, ministries, and military headquarters. Because infrastructure is never just physical. It is political. It is strategic. It is the hidden framework that decides how the visible world behaves. So in the end, this is not a story about digging through rock. It is a story about how systems are built, how they fail, and who gets to shape them when the pressure rises. And once you see that, the strait is no longer just water. It is one of the places where the world is actually governed. This was never just about a canal. Not really. It was never only about rock, or concrete, or ships, or oil. Those are the visible parts. The deeper story is about control. Control of movement. Control of access. Control of the narrow places the whole world depends on. Because that is how the modern system really works. Not as one giant machine spread evenly across the planet, but as a network of pressure points, a few straits, a few ports, a few routes where energy, goods, and money are forced into the same narrow space. And whoever influences those spaces can influence everything that depends on them. That is the real power of a choke point. Not what it makes, what it controls. A project like this would not just move tankers from one sea to another. It would change leverage. It would reduce pressure in one place and create new influence in another. It would reshape decisions in markets, ministries, boardrooms, and military commands, because infrastructure is never just physical. It is strategic. It is political. It is systemic. So in the end, this is not a story about digging through mountains. It is a story about how the world is held together and how a few narrow points decide whether it keeps moving. Control the choke point, and you shape the system around it. And here's the twist. This canal doesn't exist. Not yet. But the logic behind it is already shaping decisions today. Because the risk is real, the bottleneck is real, and the consequences are already visible. So the real question is not, can we build this? It's, are we ready when something like this actually happens? Because one day, it might, if you want more breakdowns like this, real systems, real risks. Real what-if scenarios hit subscribe, because the next one might be even closer than you think. But now comes the question every system has to answer. What happens when something goes wrong? Not a delay, not bad weather, not a mechanical fault. The worst case, a supertanker enters the canal. Then something happens. An attack, a fire, a collision, and suddenly, a vessel, hundreds of meters long, is dead in the water. Now, the canal is blocked. One ship, one section, and billions in global flow are suddenly at risk again. This is the nightmare scenario, the exact thing this project was supposed to solve, now reappearing inside the project itself. So, does everything stop? Not if the system is designed the right way, because a canal like this cannot be built as one long empty trench. It has to be built as a controlled environment. Every vessel tracked by radar before it enters. Every movement monitored by cameras along the full route. Traffic spaced and managed like aircraft on approach. The canal has to think ahead. And more importantly, it has to isolate failure. That means segmented control zones, emergency holding sections, TOW response units already in position, fire crews, recovery crews, salvage equipment on standby. If one section is compromised, the rest of the canal does not instantly die with it. That is the difference. Hormuz is open water. You react to chaos after it happens. A canal is engineered space. You design the chaos before it arrives. That doesn't make it invulnerable. Nothing this strategic ever is. But it changes the nature of the risk. The goal is no longer perfection. The goal is resilience. A system that can take a hit, contain the damage, and keep the larger network alive. That is how modern infrastructure survives. Not by pretending failure is impossible, but by assuming it will happen and building the response into the walls, the signals, the traffic logic, and the emergency plan from day one. So yes, a ship can still go down, a fire can still break out, a route can still be tested, but the real question is not whether failure happens, it's whether the system collapses with it, and if this canal is engineered the way it has to be, then even in its worst moment, it does not become another Hormuz. It becomes something far more valuable, a choke point that knows how to survive. Now we come back to the first question. If the strait closes, why doesn't the system just recover when it reopens? Because the real damage is not the moment it stops. It's what happens next. At first, the shock looks financial. Prices jump, insurance surges, shipping freezes. But that is only the surface. Underneath, the machine starts to lose rhythm. Refineries slow down when feedstock stops arriving. Storage fills up in the wrong places. Producers cut output because there is nowhere for the barrels to go. And once large industrial systems shut down, they do not restart with a switch. They restart slowly, crew by crew, terminal by terminal, contract by contract. That takes time. Meanwhile, the world keeps moving. Airlines still need fuel. Factories still need inputs. Farms still need fertilizer. Hospitals still need chemical supply chains to stay alive. So the shortage spreads. Not all at once. In layers, one sector first, then another, then another. This is where the system breaks. Not in one dramatic collapse, but in the loss of recovery speed. Because modern economies are not built with deep buffers. They are built on timing, precise deliveries, continuous throughput, tight inventories. That makes them fast. It also makes them brittle. And then comes the part no one can easily measure: trust. Once markets believe a route is unreliable, they do not simply go back to normal. Shipping contracts change, insurance models change, investment decisions change. Some cargoes never return to the old pattern. Some buyers never trust the old route again. So even when the water opens, the system that depended on it has already changed. That is why this kind of disruption is so dangerous. It does not have to destroy the global economy overnight. It only has to interrupt it long enough for restart to become its own crisis. And once recovery becomes the bottleneck, the damage stops being temporary. It becomes structural. Now imagine this route had existed 20 years ago. The last 2 decades would have looked different. Every crisis in the Gulf would still matter, but it would not hit the world with the same force. Oil prices would still move, just not like a shockwave, because the system would have had something it does not have today: